Okay, I'm recording. This is Stephen Smith speaking. The date today is 9/7/2018. Hey guys, hold your conversation down, please. I'm recording. Hello, I'm recording. This is September 7th, 2018. This is the regularly scheduled lecture meeting of ITSE 2309 at Collin College. And this is actually about the first formal academic lecture that we have. Today we are in Module 3. Okay, Module 3, in the title of the Module 3, it says non sequitur in text. That means it's not in order. I don't know why they don't begin with this material. They really should begin with this material, but they don't. So I'm making the assigned reading. We're jumping way ahead in the textbook to get this stuff. It's pages 340, 341, and 344 through 351. And it's in chapter 11. I don't know what it's doing up there, but you need to understand this material, at least something about it, before we start talking about starting to use a database. Lots of times database, in my opinion, they get the sequence of the class wrong. So I'm going to back up here and talk a little bit about it. SQL, we're here to learn SQL. Now, everything that we do in SQL, we probably have a graphical user interface, a GUI, that does it for us, or something similar to it. In Access, for example, you do about everything, creating tables and all that, using the graphical user interface. This isn't a class about the graphical user interface, even though we have one. Even though you may use it to validate your data, if you want to go over there and look at what you really have, I'll show you more about the graphical user interface. But this class isn't about that. This class is about SQL. SQL means, well, it means SQL. It's sometimes called SQL, structured query language, simple query language. QL probably means query language. Well, it's an ancient programming language. You can trace SQL back to the 60s when it was very much very similar to the way it is today. And in terms of computer programming languages, that is really old, geriatric even. So let's see, this is the table creation. And to apply, the students will talk about the difference between data definition and data manipulation. The first one, when we are creating tables, this is called data definition. We are defining our tables. And in my opinion, data definition should come before we start working with the data. It doesn't make any sense to talk about working with a table until we understand how a table comes into existence and what it means to have a table. Okay, so that's my objective today. Data manipulation allows us to change the data in the tables. So data definition, think of it as creating tables. Right now, that's the only one you'll know. So it's okay if you think that data definition means creating tables. There's other things I can create. Data manipulation means putting data into the tables, taking it out of the tables, looking at it, manipulating it, answering questions about it. Okay, we have in a database, all databases, fields have a single value. Let's see. Everybody hear me okay? Josh, are you hearing me?
Yes. Yeah.
Okay, very well. Thank you. I just wanted to make sure this audio has been kind of squirrely, but it looks like I'm recording. Okay. My fear is that I'll end up without an audio recording here. Fields have a single value. Now, can a field have more than one value? Is it possible? Yes. For example, how many phone numbers does the average person have? Let's say they might have a landline, they might have a cell phone, and then a work phone and all that. We do not want to put all of those into one field. That would make it have 3 values. If I have a text field that has, let's see, they're 10 characters each. If I had a text field that allowed me to put 30 characters in there, I could put all 3 of them in one field. That is violating that rule of first normal form. You should not have your first name and your last name in the same field unless you're always going to access them together. Later, we're going to see that that field sometimes, that idea sometimes gets violated. It happens. People get first name, last name, they'll put them both in the same field, and then the database programmer usually has to go and pull them apart. Second one, no duplicate rows may exist. No rows that are duplicate in all fields, no completely duplicate rows. That being said, is there something about that record, that entity, that whatever it is? The first one I'm going to use is an employee. If you had an employee, is it possible to have two employees with the same name? Sure. It's possible to have two employees that have the same phone number? Absolutely. Could they have the same address? Absolutely. Is there something unique about an employee I can point to and say, this is always different? Social Security number. The other thing that I have to say about it is everybody has to have one. Well, you can't be an employee unless you have a Social Security number. So Social Security number is the first example of a primary key. There could be others. I could use a date. I could give you a temporary ID, yes. If it's issued by Social Security, then that's fine. That's a Social Security number. Or I could give you one to allow you to be in my database. To be in my database, you must have a Social Security. You must have this number, this field, and it must be unique. This field is called the primary key. I prefer it to be one field. It can be more than one, but I prefer it to be one field, so that we are saying that that field has to be there. It cannot be empty. We say null, cannot be null, and it must be unique. When I say it's a primary key, that's what I'm saying. The other rule is we access a database by content only. That means I will never say, what, never? Yes, sometimes we do say that. But we will never say, give me the third row. Give me the fourth column of the third row. It is a violation of this idea to say, give me the 10 greatest rows, unless you order them and specifically take the top 10. This one is, again, can be violated and sometimes is, but in a database, we only ask for, show me all of the people who live in Frisco, Texas. Show me all of the people who live in zip code 76209, wherever that is. I will access by the content of the row. The fastest way to access, to get to one record, is to access by the primary key. Because when we create a primary key, we are implying that the table will be sorted by that primary key. So it gives us an ordering to the table. Even though we say there is no order to the table. And that's true, we pretend that there isn't, but there is. Ask a question, please.
Is that specific to table level, or is it specific to the database?
Primary key is on the table. Yeah, question was, is a primary key a property of the table or the database? The answer is it's a property of the table. All tables, before I'm going to accept them, that they are a database table, they must have a primary key. So they must basically conform to these three laws of database. Have a primary key is the big one. Single value, if you have a field that has first name, last name in that field, I'm not going to throw too big of a fit, but I'm going to try to break it apart as soon as I can. And sometimes we do access by row number, but this is not a spreadsheet. In a spreadsheet, we access by row column. Database, we access by content. Other thing about a database is huge. Okay, it is too big to fit in memory. Therefore, a database exists on the disk. So a database is all about reading from the disk and writing back to the disk. It's everything. Its speed depends on how fast it can do that. It typically, we have a question about how much memory and computer resources does your database need, and it's a joke. You know, the answer is all of them. This is why I suggest that you shut down your database on your personal machine. We're going to create tables. Well, that's what we're going to do today. Okay, we're going to talk about 3, 4, and 5 now. There's the assigned reading. Next. I'm not going to read you the objectives. I'm going to get right to it. It says our text editor will be Notepad++. Instead of saying our text editor, maybe I will edit that and say a good text editor if you want to use it and you don't feel like starting SQL Server. Notepad++ is a nice, simple little text editor that will fit on a USB drive easily. It's not very big at all, and it will create your tables. Now, you cannot run your tables. You can't run your code from Notepad. It's not the database, but it will edit database, and if you set your language to SQL, it will highlight everything as if it were being typed into it. So Notepad is a cute little editor to have around. I'm not going to spend a whole lot of time on it. SQL is the native language of database. Like all languages, it tends to have dialects. In theory, it is supposed to be universal. The idea, if you say it's SQL, it's supposed to run on any SQL platform. This is not so in practice, but it is generally so. I will try to point out those things that are not, that you'll have to change if you move to another platform. In Access, if you, any Access people taking Access, ITSW 1307, or is it 1407? I don't know here. Access runs on SQL too, by the way. You just don't see it. You have to drill down into it a little bit to find it. But if you go to your SQL window, you can see it, and it is a dialect. In this class, we will try to stay with pure SQL. And then I point out, what is pure SQL? It's not possible to write something that will run on any platform. But I'll try to point out those things that are not. Databases have a graphical user interface, but this class isn't about the graphical user interface. We'll be looking at it from time to time. I'm going to keep going here. This is a little tutorial on Notepad if you want to do it. What is this? That's one of my recordings. Okay. There's a demonstration file. Reading assignment again. Primary key is a field that uniquely identify at most one record. What would make the best primary key? And it's pretty obvious: a person's name, hair color, social security number, or phone number. Obviously, you just answered the social security number, probably on a quiz. If you choose the social security number, all of the others may be duplicated. Everyone has to have a SSN. To be correct, all tables must have a primary key. One of them. I prefer it to be one field. It is possible for it to be two fields. In that case, both fields must not be null. They have to have something in them. And together, they must be unique. Okay, I say please open the file, create one. This is just a dummy name I made up. It says, please change the database name. Okay, here's your first instruction. All of your files that you hand to me must, the first line of the file will be the first executed line. Now you can have your name at the top if you want. First executed line will be use and the name of your database. Use your database. Now, if you have a default database set, and you should have a default database, then if you just create a table, it's going to go there. But you'll say use Mine's going to be probably SW Smith underscore DB, perhaps. I forget what I named my database question. Okay. So I'd change. This would be your database name. Go is, this is a comment. Dash dash is a comment. Kind of like in C, it would be slash slash. Well, in SQL, it's dash dash. The C form of the comments of slash star, slash splat, or star, asterisk, starts a comment. It goes until you get a asterisk slash to close it. So it's just like C also. So either form of them work. And that's typical in database. This next statement here, let me just go over to the next statement, and that one is go. Now, go, I'll talk about if object ID in just a minute. Go has the effect of saying, okay, clear everything off, all of your variables. Now, the use stays in effect until you change it. But everything that you have created in this, well, not everything, a variable that you have created, but we don't create variables. Go breaks this up into multiple scripts. Okay, it is a good idea to have a go before and after a create statement. Right now we're doing create. If you're just looking at the data, you don't have to say go every time. If you did, it wouldn't hurt anything. Go is not pure SQL. It is unique to SQL Server. Okay, so go says, clear everything off, get ready. This is the start of the script. And so this is a SQL program. Now, from line 11 to 18 here is an SQL statement. It is best not to have any completely blank lines inside of an SQL statement. Outside of it's fine, many as you like. Inside, from the place where it starts, it says create until it finally closes. Don't have an empty line. SQL Server will not care. Others will, so get out of the habit of putting in blank lines. If you need to put a blank line in, put a comment on that line, put a dash dash on that line. Now it's not blank anymore. Oracle, for example, and this is not a class in Oracle, but if it were, you wouldn't be able to have a blank line. Okay, so we start off with the table we want to create. Create table employees. Think of it as I'm designing a card index, and I have to decide what one of these cards looks like. So I'm going to define what the fields are on this card. How big are they? What are they? Okay. First ones I'm going to look at are char. If it's C-H-A-R, that is a character field. How many characters are in that field? Notice I didn't say can be. How many characters are in that field? This first one, I always put the primary key first. That's my choice. There are exactly 9 characters in that field. If you don't put 9 characters in that field, it pads it out with spaces for you. Okay, so if you only put 4 characters in there, you're going to have 4 characters and then 5 spaces at the end. That's okay because spaces don't typically mean anything when you're sorting and searching a database. Okay, questions. Then there's a comma between it. So it's a little bit different of a syntax than you're used to. Basically, I'm defining a variable that is an array of char. Okay. That's the Social Security number. All Social Security numbers have 9 characters. I don't have to store the dashes. If they're in the same place all the time, I don't store them. Okay, a name. How big is a person's name? Well, I need to get it big enough. Go ahead.
Oh, okay, thanks. Wait, is there a data type for storing just numbers? Or?
Yes, there are data types for numbers.
Oh, so the Social Security all numbers.
Okay, the question is, a Social Security number is numbers. Why don't we use an integer data type? And the answer to that question goes like this. Does it make any sense at all to add, subtract, multiply, and divide a Social Security number? If it does not, then it is a character field. Okay. Phone numbers again would be characters. Zip code would be characters. It does if, for example, a person's body mass or weight. That would be a number because it makes sense to, if we were all getting on an elevator, we would add up our body weights to see if it was safe. So it would make sense. The money in your pocket could be less or more than mine. A Social Security number, it doesn't make any sense to do mathematics on it. So we make it a char field. It's a little cheaper to store it as character data than it is to store it as a large integer. Other questions? What database are we on now? Okay, now at the beginning of this script, you said use some database. My database happens to be named Scratch because this is where I'm just creating junk tables. If you name it junk, whatever, this is your database. One you created last time. That might have your name on it and DB. Okay, so we're just creating some tables. We're playing around with them here. Question was, what database are we on? Your database. Second one on line 14 is ename. Name is a variable length character. So varchar allows it to, excuse me just a minute. Varchar is a variable length character field. It can grow and shrink. Tickle cough. Because a person's name isn't always the same. I typically do not use varchar unless it's a fairly large field with a wide variance in the characters. 16, think about it. The cost of making it a char field instead of varchar, the cost is in the amount of storage I would have. Excuse me, the saving would be in the amount of storage. Make it a varchar, I would use less storage space. If I make it a char, I'm going to use less computational overhead because I don't have to grow and shrink all the time. I just store it in there. I know exactly how big it is, and I don't have to fool with moving stuff around in memory. Okay. So in general, for small fields, and by a small field, I mean anything under about 64 characters, in the real world, would be probably char. So if I had a 48 character field, I probably would not make that varchar just because of the overhead of shrinking and growing. There's different opinions on that. Yes?
What does the 16 mean?
16 means it goes up to 16 characters. In a char field, if you go over 9 characters, you'll get an error. In a varchar field, if you go over 16, it simply truncates it, I think. That's the way it works in a lot of them anyway.
So what if you have like a long name?
Right, you would have to push it up. The problem with really, really, really long names is that all of them are going to be the same. So I'm going to allocate that much space to all of them, so that might argue in favor of a varchar field. It is not good to have a field that is too big. It is disastrous to have a field that is too small. Someday we're going to run out of Social Security numbers. Not too far in the future. We're going to run out of them. Remember Y2K, year 2000 bug in computers. So most of you guys are old enough to at least remember it. Year 2000, the world was going to end because the date was too small to hold. Everything would be interpreted as a 1999, and when it went, because all we were storing was the 99. And 2000, it would flip over to 0. All computers will do that. Anything, any any value you can name, you can get too big for it. So we're about to run out of 9 digits. Now, what we can do with Social Security numbers would be, well, we could go to letters. We could include, that'd buy us a few years. Questions, there's 2 fields. Yes, we also have integer. Either you can either spell it out as integer or yes, there's a floating point. We do not like floating point. The floating point is called real. I'm going to talk about that. That's going to be a topic of a whole lecture. Floating point numbers have errors in them. We like to stay in integers anytime we can, and we find that usually we can. If I know how many decimal points a number has, I can just shift the decimal point out and treat it as an integer. I'm going to talk about the constraint. Here's a named constraint. What does constraint mean? Constraint means that I'm telling you something that's going to block some things that you can put in there. And the constraint, introduced by the reserved word constraint, then it has a name. This is a named constraint. It has a name. I'm going to talk about one that isn't in a minute. What is the constraint? Primary key. When I say something is a primary key, what is a primary key? ESSN is a primary key. What's the constraint then that is really on it? 1, has to be there. Cannot be null. 2, must be unique. Okay. Now, sometimes you will see it done like this. That is sloppy programming. And I got a red line there because I can't have the primary key defined twice. So I define primary key. It is possible to define it all on the same line. The problem with that is if you violate that primary key, it creates a primary key, excuse me, just like always. But if you violate it, you get a very cryptic message. If you name the constraint like this, and you try to put in a duplicate or a null, you will see the name of that constraint as part of your error message. So we will always name the constraints. I'm going to show you 3 of them today. This is the first one. The constraint is the primary key, and that's separated by a comma. Okay, here's another constraint. Constraint. I tend to make my constraint names long because I will almost never type them again. All they do is really sit there and they give me information. When something happens and goes wrong, it tells me where to find it. So I want to know what table it came from and kind of what is it. So the constraint says null e name. Notice that this is the employees table. I have named my fields ESSN, E name. Not everyone will do that. This says if I see a field, I know what table it comes from by looking at the first letter or the first 2 or 3 letters. If I need more, I'll get more. If I have 50 tables, which isn't unusual, I will use as much of that table name as I need to get a unique identifier for each field. So when we get over to the next table I'm going to do, that will have unique fields. These are fields. Also, some people call them columns. I call them fields. Constraint, E null, E name, and this is a check constraint. Check, E name is not null. Now, we do not say equals null or not equals null. We say is null or is not null because equals means is the same thing as, and null is not a thing. Null is nothing. Nothing is not equal to nothing. It makes no sense to compare them. Is my car older than, younger than, the same age as your car if I don't have a car? It makes no sense. So we say is null. So this is how you do a check. I'm going to show you some others as we go. This is an example of a check not null constraint. You can also check as, you know, is it's equal to an A, or it's equal to a B, or some, you know, you can check anything that you can write there easily. You cannot access another table. Question, please.
So is not null, is that like one command or just 3 different words?
It's 3 different words. Yeah, you could say is null or is not. It wouldn't make any sense to check that it is null, but there is no comma after the last one. I think SQL Server will let you put a comma after the last line. Oracle will not. Similarly, it closes with a parentheses. I like it when you align your opening parentheses with your closing parentheses and indent everything in between. This is good programming style. SQL is not case sensitive. Okay, SQL is not sensitive. Uppercase, lowercase are all the same here. Nonetheless, we use uppercase and lowercase to show things, and the convention is that we write reserved SQL words in all uppercase. Okay. So what's turning blue? I put it in uppercase. When you know it's, you're telling me when you write it in uppercase, if I'm looking at it with Notepad, which I can, and I see that uppercase word, I say, aha, that's a reserved word. When I see a mixture of them, I see, for example, this one, this employees PK it's a mixture of uppercase, lowercase. Okay. In keeping with good programming practices, none of our identifiers have a space in them. No identifier may have a space. Now, you're going to find out that that isn't true. You can put them in square brackets and you can put spaces in them. Your instructor is going to throw a fit if you do that. Okay? No spaces go in any identifier in any programming language, or I'll get even. Okay? You don't have to put spaces. There's no reason you need to put spaces, so don't. Use the same rules for identifiers that you used in your, most of you have had one programming class, I'm going to guess, maybe C. Use the same rules and everything will be fine. What's the rules in C? Begins with a letter of the alphabet, followed by 0 or more letters, digits, or the underscore character. That's going to get you through 99% of everything that you do in programming. If you follow that rule, then you'll be okay most of the time. You'll see people that will put a space there, and I'm still going to, excuse me, I'm still going to have an error because I've got it down here, but they put a space there and then they put it in square brackets. There is no reason to do that. So if you want a space, don't put a space, put an underscore. Questions? So before I have a go, what is this? That's just a comment. You just hold down the dash and it goes across, and the first two make it a comment. So go, another go. Okay, this is another program, 2 separate programs running here. That table was created, it stays created, no problem. Now, how do I create, what time am I? Take a break in
That's the question.
15 minutes or so.
Can I ask a question?
An employee has dependents. Notice I said dependents. How many dependents can an employee have besides himself?
I guess unlimited.
No particular upper bound. Can he have 0 employees besides himself? Excuse me, 0 dependents besides himself? Yes, he can have 0. Can he have 3? Yes. Can he have 300? I suppose the IRS is going to really get soggy and hard to light, but you know, I'm not the IRS. So how do I do this? And the answer is I need a one-to-many relationship, and this brings up the idea of the foreign key. Now, when I have dependents, this is how it is done. The dependent has a primary key. When you see SSN or ID, I'm telling you that's a primary key, because I always name my primary key something that has ID or SSN. When I was in school, Imelda Marcos was prominent in the news, and the story was that she had thousands of pairs of shoes, and so we were always writing databases to manage Imelda Marcos's shoes, and we had to come up with a unique shoe ID. So it had to have a primary key. Another one is pets. Some people have asked me about the one in the assignment. Some people are trying to do the assignment. A dog doesn't have a number. Yeah, I know, you got to make one up. Talk about that a little bit more, but this is DSSN. Now see the D table, D, SSN, dependence, SSN. The D, dependence table, D name. Here's one that doesn't fit into our scheme of things. What is that one? That one begins with an E. It doesn't belong really in this table. What does this do? This takes me to one single record in the employees table. Okay? How do you do this? Listen carefully to what I'm about to say, because I promise you this is a test question. How do you create a foreign key, or how do you create a one-to-many relationship? We have a one side. One employee has many means 0 or more, dependents. One side, many side. The primary key of the one side is copied over into the many side. The primary key of the one side gets copied over into the many side. It must retain the same data type. If it's char9 up there, it has to be char9 down here. It can't be an integer down here if you're going to make it a char9 up there. Okay? It should keep the same name, but it doesn't have to. Sometimes you will see it will change. Sometimes it has to change. Sometimes I don't have any choice. But it must match the type. The type must match. Make the name match if there's any way you can, because notice how this one calls attention to itself. This is an important field. This is the field that tells me what the primary key of their employee sponsor is. Therefore, if I say I want all of the D name where the ESSN is 3456, if that were a SOCH, then I might get 10. They might have 10 dependents. Okay, I might not get any. They might not have any dependents. So therefore, if they don't have any dependents, then their social security number, the ESSN, just never appears in that table. No problem. Don't have any null fields. If I do have any dependents, then I will have one or more of them in here that match that social security number. Therefore, this is called a foreign key. A foreign key does not have to be unique. If I demanded that it be unique, then you could only have one child, one dependent. Go ahead.
Does the foreign key have to be like a unique primary key in another table? Or can it be another key?
Can it be? Yes, it can be, but it almost never is. A foreign key almost always references a primary key. It doesn't make any sense if the field that it's referencing can have duplicates in it, because which one would I be talking about? So it is, it has to reference a unique field. And that is usually, if a field is unique, I can count the number of times on my 10 fingers that I have ever written a field, constrained it to be unique, and it was not the primary key. But it's possible if the field that you're referencing, I call that the parent. If the parent is unique, then it's possible. Almost never happens. So the foreign key typically references a primary key. That's going to be the case. That everything we're going to do is going to maybe not. Maybe there's one case in the class somewhere where it doesn't. But notice that the constraint that it puts on this, okay, the first constraint is just a primary key. We saw that in the last one. So is this saying that the DSSN is the primary key for the dependence table? Okay, ho-hum. Now let's look at this, at the foreign key constraint. I usually put I usually go up with them because the constraint is in the dependence table. Dependents referencing the employees, so I'll usually put dependents first, employees second. That's my way of doing it. And then I put FK. PK means primary key, FK means foreign key. To me, when I read it, there's no me. You could call it X if you wanted to, but that wouldn't give me much information. It is a foreign key constraint. What is the foreign key? ESSN. I have two ESSNs. Which one am I talking about here? The one in which table? The same table. I'm talking about the one in the dependence table. Okay. References employees ESSN. There's a couple of other things that you can put on it. This is sufficient. Unto the day is the evil thereof. Okay, what am I saying then if I say it is a foreign key about that field ESSN? Can it have duplicates? Yes, it can have duplicates. One other thing, unless I say otherwise in a third constraint, it can be null. It's okay from a database perspective for a foreign key to be null. Now it might not, it might really stink from your operational world to have a dependent that doesn't have an employee sponsor. Wait a minute, something's wrong there. We call those orphans. Having an orphan foreign key, a null foreign key. Okay, but it is possible in a database. That doesn't hurt the database any. Okay, there's nothing wrong with having an orphan unless it's wrong in your organization, in your way of thinking. If it's wrong, then put a constraint there that says check that ESSN is not null. Now you have to have a sponsor. But what a foreign key says is that if you have one, then it must appear in the parent table, in this case, the employees table. Okay. I talk about them parent-child. Go ahead.
In the case where the dependent is also an employee, their social security number would be parents would also be.
Yeah, that's bringing that. Right. In this case, they would have an entry in the dependents table. So I would not be I am my own dependent by definition. That's another issue. So I am my own dependent. We'll just assume that everybody has one that's themselves. If they have any more, they go in here. Now, if my daddy also works at this company, then I will appear in the dependents table. I will have my dependent ID and my father's EID. then I will also appear in the employees table. That gets a little tricky. I can't claim myself as a dependent if I'm a dependent of my father. Well, I'm aware of that. This isn't a class on IRS. I think you'd run into some IRS issues there, and we'd have to work around it. Right now, I'm just trying to get two simple tables. Yeah, okay. I agree you can work and still be a dependent. Can you claim yourself as a dependent if your father is claiming you as a dependent? I don't think so. One time when I was teaching at Austin Community College, I wanted to take an associate's degree, and they told me I had to take C programming because I never had credit for it, but I was teaching it. So they gave me vouchers. So I signed up for my own class using a voucher because I didn't have to pay for it. So I signed up for my own class. Yeah, about the same thing. Almost flunked. Teacher was a jerk. Okay, let's see. Anything else? Let's see. I put on my headphone now so I can hear everybody. Everybody doing okay?
Yeah, can you hear me?
Yeah.
Okay, Wesley, you doing okay? Wesley, I see you're muted. That's fine. Let's see who's.
No, I have a question.
Okay, Wesley, go ahead. Let me unmute you. Wesley, if you need to talk, you need to unmute your microphone.
Okay, sorry about that.
I can hear you now.
When you create a new table, I see in the book they use the word new. Do you have to use the word new when you create a new table?
The question was, do you have to use the word new when you create a new table? I have never seen the word new used in SQL. So they did it like this: create new table.
For example, they got create database new _ AP.
Oh, okay. So the question is, they had the example was create table or create database, and the name of the table or the database was NEW _ AP. That's just part of the name of the object that they're creating.
Okay. And the other question is, when you talk about the var char, is that word stand for variable, character, variable?
The word, a question on the word varchar. The word varchar does stand for variable length character field, but it's varchar. It's just a reserved word, but that's what it means.
Got it. Thank you.
Okay. Well, I'm gonna mute your. Okay. Anybody else, Josh?
No, I do have a favor though. Can you go ahead and mute my head though?
Mute your head.
No, my head.
Yeah.
Thank you. And that's it though.
Okay. I typically try to keep them muted as they come in. I put you on mute, but I think you can. Well, I usually let you mute yourselves, and then that way, if you need to answer a question, I have the my headset around my neck, and I can usually hear you if you yell. Okay. Anyway, I try to take questions from online. I wish I had the speaker in the room, but if I go to that speaker, then I lose my audio recording. Okay, let's, I'm gonna run this code, and let's see. If I'm gonna go ahead and put an error in here. On line 21, I put an error, and so I'm going to say execute. Now, when you execute, be sure you don't have something selected. Otherwise, you're going to get an error. It's just going to try to run just that selection. Oh, before I execute, I wanted to do a couple of questions. Which table do I have to create first? Employee, because the dependence table has a foreign key, so creating the dependence table depends on creating the employee. It is possible to create the dependence table first and then go back and put in the field, but I'm not going to teach it that way. Okay.
Your
Yeah.
comment about not highlighting something, is that only in the case where we're running this interactively?
Yes.
Like in a batch mode?
Well, it is possible simply to just create one table like that, and now you would just run that piece of it. For creating the table, it's probably not going to do it. Okay. Which table do I have to put the data into first? That's our next topic after break. We're coming right up on break. Which table do I have to populate first? In other words, I had to create the employees table before I could create the dependents table. Now I have to have an employee before that employee can have children. It's okay to create one employee and all of that employee's children, or you can create all of the employees and then all of the children. It doesn't matter. If I were going to delete a record, which record, if I wanted to delete an employee, what would I have to, can I delete the employee without deleting the children? If I did that, then I would create an invalid foreign key in the children. So it's going to block me from doing that. If I am throwing the tables away, I say get rid of the tables, and I'm going to go up here now to the first line. Okay, let's talk about these lines right here. This table, this one right here. Number 3, if object ID dependence is not null, drop table dependence. Now, if I say just drop table dependence, SQL is strange. That is an error if dependence does not exist. Now, if I teach logic, it is illogical to me that would be an error, but it is. If you try to drop something that you don't have, now in my opinion, if I don't have it, then it's already dropped. I don't have a problem with it. I only have a problem with it if the post conditions don't agree with what I'm expecting. So if I try to create a table and that table already exists, maybe I have a problem because I can't create it. I don't know what to do. I don't know whether to change it or drop it or do what. But if I drop a table and that table does not exist, it causes an error, and that error causes my batch file to cease executing. Okay, kind of a bummer. So this is the way we get around that. We have we use an if. If is not a part of SQL. If you want to learn about if, then you have to take my ITSE 2347 class, which is the Advanced Database Programming. Okay, this is the way it's done. I will give you this file. I'll send it out as an attachment to an announcement so that you have the same file that is as it got finished with, and it might not be the one. If I put it, I always change them as I'm going through the class. Basically, this says, if there is such a thing, then drop it. Which one do I have to drop first? Dependence. Why? It's got a foreign key into employees. If I drop employees first, I will have it. I will be violating the foreign key. I cannot violate the primary key. I cannot violate the foreign key if I put those constraints on it. So I drop them in reverse order. This is important because this is somebody will try to drop what do I have? Owners and pets, I think, or something like that. I mean, sometimes I do doctors and patients, and I don't know. I do all kinds of different stuff. But you're going to have to create the parent table first. When you drop the child table. Now, if you use this if object ID, If you just say drop table dependents and there is no dependent, okay, I'm going to execute. So the first time through, it did fine. It says fine. Now when I try to do it a second time, I get an error. It says it can error level 11. That's a fairly severe error. It causes it to abort. So I wouldn't, that's as far as I would get. If I just said drop table dependents, drop table employees, I'd never get past the first one because I never get to the create. So I have to run it like this. I put an if it is not null, that means if it exists, then drop it. If the parent table exists, then drop that too. If it doesn't exist, fine, don't do anything. So this, well, when I run this, when I execute this, I get the message that the command's completed successfully, and I get a nice warm fuzzy feeling that my code has worked. If I accidentally have something highlighted in there, and you will do this, I do it all the time. You'll see me do it before we get out of here. I get an error message for my reading pleasure. Notice that it says what, line 3. So it takes me to, don't have anything highlighted. I need to show you quickly, did I show you how to turn on your line numbers? Okay, at home, get out your pencils quickly and make notes here or it will be in the recording. You go to your tools, from the tools menu up at the top, tools, pull down to options. And from options, you go to text editor. It's the second one down if you don't have anything expanded. Text editor. You're going to go down to all languages, boom, and general. So text editor, all languages, general, and notice that one of them about halfway down is a little checkbox that says line numbers. If you check that box, line numbers are enabled. If you just do an installation out of the box and don't set it, then it'll stay set until you change it. But that's a handy thing to have because it lets me go straight to the line number when I have an error down here someplace. There's an error on line 32, so when I execute, it says line 32. That's a pretty good indication of where it is. As you well know from your programming experience, the error isn't always on the line where the compiler stops. Sometimes the error happened long before that. Questions? Okay. Questions from Usenet, from Zoom land.
Can you hear me?
Josh?
Yeah.
Go ahead.
So the only reason you're doing the if statements is to prevent duplicates, to prevent creating duplicate tables?
The only reason I'm doing the if statements is to prevent duplicate tables. No, I cannot have a duplicate table. I cannot have a table in the database named the same as any other object in the database. So I'm doing that to prevent an error that will abort my script.
Okay, all right.
If I did not have that, I'm going to take that if out right there.
Mm-hmm.
It's flagging it in red for me because it says that's going to be an error, and it will be because as soon as I try to run it, I hit line 4 and it aborts. So unless I
see what you're doing. I see what it is.
So when I execute, I have to be able to check it, see if I have one. Now, if this is true, I have one, then drop it.
Okay.
Okay.
I see.
Questions? Okay, we're going to take a break right now. I'm going to pause the recording. I was just about to talk for 45 minutes here and not have recorded it. So I was saying that I'm going to make the make the assignment in module 3 due. It's I believe it's creating. I change them from semester to semester sometimes. Sometimes I do and sometimes I don't. And let's see. So I'm going to make it due, I think, Wednesday. That gives you a weekend and a couple of days. It's not that big of a deal. You're just creating 2 tables, and then we're going to insert some stuff into the tables. And when it tells you to, I think it is the, if it's the one I think I gave, it's owners and pets. An owner has 0 or more pets. Whenever you see that, owner has 0 or more pets, that's a parent table and a child table. 0 or more means it's a foreign key. So the owner's foreign key comes down into the pets table. It's pretty much analogous to exactly what we did. Foreign keys, I'm looking for exactly the same thing. So if you just take my examples and rename it, don't just rename the tables, rename the fields also. So I don't want to see employee SSN for the pet ID or the owner ID. You know, make up your own. You can also have, let me give you a couple of other things here. It is also possible, I guess that's an integer. It can be int, I-N-T, or you may spell it out, I-N-T-E-G-E-R. Most people just use the abbreviation INT. There are some other integers. That particular integer is a 4-byte integer. As most integers are, and it's gotten pretty standard. So we also have a long integer that can get very, very large, and we have a short integer, which is long is type long, and then short is named short, and then we have another, a short has 2 bytes, and then we have a tiny integer. A tiny integer is 1 byte. And its numbers can be 0 through 255. Once you hit 255, it overflows. It does not have negative numbers in a tiny. Let's see. We do not have a Boolean data type. Okay, we do not have Boolean. If you need to have Boolean, you either use a tiny int and make it be 0 or 1, or you use a char 1 and make it be the character 0 or the character 1 or the null character or something. Reason we do that is because I really cannot access one single bit. It is more trouble to get one single bit, call it a Boolean data type, than it is just to go ahead and say, if you want a Boolean, that word means something to everybody? True or false, right? You just have to make it using a tiny int. Tiny int is about as small as you can get, 1 byte. If it's 0, it's false. If it's not 0, it's true. But you have to do that in your code. Okay. Money. In some, excuse me, in some databases it is called currency, and in SQL Server they call it money. Money by definition has 4 decimal places with it, not 2 like we think. Money is broken down into 4 decimal places. Therefore, it is possible to have something that costs $23.46 and 33 hundredths of a penny. Okay, so that's because money is issued in 10,000ths increments. There is a coin that exists, it's not in circulation, such that 100 of these coins make a penny. And that is the smallest granularity of money. So 1/10,000th of a dollar. Most of the time people are only worried about pennies. The reason for this is if we fix that decimal place someplace, it's very easy for me just to shift it out. I'm never going to store your salary as $27.53 an hour. I'm going to store it as 2,753 cents an hour. And then just put the decimal point back in when I want to see it. So money works that way. Money is an integer, even though it has 4 decimal places. It is an integer. There is another one. Notice on this one, I'm using what they call the camel case. There are 2 different ways of writing variables that are perfectly acceptable. Sometimes people will use underscores. I tend to use underscores because I'm a C programmer. Java programmers will tend to go with what they call the camel case, where they use uppercase, lowercase. It begins with a lowercase typically, and then after that, every time a new word comes up, it is in the it changes case. It's perfectly acceptable.
So the question on the money, does it actually store it with the decimal or places, or
No, sir, it stores it as an integer. So when you write it, when you type a value into it and you insert it, unbeknownst to you, it is shifting that decimal place by however many it has to. It shifts it by 4 to the right. And then when it shows it to you, it shifts it back in 4 to the left. Of course it knows how to do that. It's a computer. Now, anytime that I fix that decimal point and I say all of these numbers have 4 decimal places to the right of the decimal, it stops being dollars and it becomes 10,000ths of a dollar. Decimal point just automatically shifts out of it and I store it as an integer. But you want to see it as money, so when the system shows it to you, it puts the decimal back in. This saves us a whole lot of trouble. We love integers, we hate floating point. Okay. Reason for that is that lots of things in the world that I just cannot represent as an integer. Anything that has to do with a circle, an angle. If I have so many degrees, well, I cannot ever give you a degree because a degree has a factor of pi. Now I've got an irrational number, but someplace I've got to chop it. So I like integers, and I don't like real numbers. Sometimes I'm stuck with them. Let's talk about numeric. Sometimes called number, N-U-M-B-E-R, sometimes called decimal, D-E-C-I-M-A-L. They all mean the same thing. This one uses numeric. This also uses decimal. Numeric and decimal are the same thing. This number has 8 digits. It is big enough to store 8 digits. You might say, oh, but that's base 10. Yes, I know it is. It's obviously going to have to go up to the next power of 2 and then end on an even byte someplace, probably an even 2 bytes. But it might be bigger than that, but it won't be any smaller than that. 8, 3. Okay. 8 digits, 3 of which are numeric. 8-3 means it has a total of 8 digits. 3 of these digits appear to the right of the decimal place. That will be the case for all values that are in there. So if I just give it a number like 54,321, 54321, that will be that, and then nothing after that. It will store it with 5 digits, a decimal point, and 3 to the right. The way it will really store it, shifts it 3 to the right, stores it as an integer. Then when it shows it back to you, it shifts it back to the left. and shows it to you with the zeros on it. Well, I don't know whether it shows it to you with zeros or not, but it handles it. It handles it, so this number is an integer. Now, the reason we like integers is an integer is exact. An integer is absolute. 3 is 3. When I start talking about a number that is a ratio, for example, 1/3, excuse me. If I want to talk about 1/3, how do I get that? Well, what is that in a decimal form? 0.1, 0.333333333, and you keep going. Some point you just have to stop. Okay, and when you stop, you've introduced an error. The other issue is that if you talk about a number, when does a number repeat? Or when does a decimal repeat? When does it not repeat? And if you talk about something like 0.2, 20 cents, does that decimal, when you shift out of the decimal and you want to see it as a fraction, 20 over 100 or 2 over 10. If I divide it out, does it repeat or does it terminate? Well, the answer is, of course, it terminates. 2 goes into 10 5 times. 2 tenths. 2 divided by 10. So 0.2. Okay. But when you shift into the binary, when you shift into base 2, computers are base 2, it does not terminate. Why? Because it has a factor of 5 in the denominator. It cannot terminate if it has anything except 2's in the denominator. When does one terminate in base 10? When the denominator contains only factors of 2, only 2 and 5. 2 and 5 are the factors of 10. So if you look at it, 1/2 terminates, 1/4, 1/5, but 1/6 does not terminate. Why? Because it has a factor of 3 in the denominator. Okay, so it will never terminate. If they cancel out, then it's okay. So like 3/6 reduces to 1/2, now that terminates. But 1/6 will not. 2/6 will not. That will have a 3 in it, so it's always going to have a repeating decimal. Anytime I get a repeating decimal, I have problems. So I want to stay out of that world and get into integers. All of these are integers. And let's call it IQ. IQ is a ratio. No, it's float. The term real has been depreciated. That is a float, and a floating point is what we don't like. A floating point introduces errors into our calculations. We avoid those every chance we get. So there's some, one other. DOB, date. Always forget this one. The date, the default format for a date is, I believe it's day, month, year, 2-digit day, month, I believe is the default format. I'll check that before I put this out. Okay. So for example, today would be 07092018 with slashes between it and then single quotes. Okay, I wanted to get to the next, let me go do a save. Create, I'm gonna call this create 9.7. .sql. And I will send this file out to you. Yes.
So like when I imported or when I brought the database into Management Studio, there was like that code, right? The SQL code.
Okay.
Like how can I get the SQL code back from this?
I'll let me take that there during lab. Okay. Because that's a specific question, and I try to take those and what can I do? Let's see. Right now, I want to go back over to. Okay, I'm going to go to my modules. I'm going to go to the next module now. So we've created tables. Data manipulation. It says prerequisite. That means that you have to have gone through module 3 before you can do. Okay. Given that you have created your tables, inserting data is fairly simple. Well, theoretically, but I have to create the parent rows first. So if I want my employee number 1, 2, 3, 4 to have children, I have to create employee number 1, 2, 3, 4 before I can insert his or her children. Okay. Insert command looks something like this. This one I'm using, my example is doctors. Insert into doctors. I guess I can go ahead and put them in this one. So I could say insert into employees. Some people will say employee, some people will say employees, a big argument over that. I don't choose to get into it. I don't know, you decide. Employees, then comes what fields am I going to insert? What fields in the employees table must I have? Must have a primary key, okay? Now, I'm probably going to name them in the order here. So I'm probably going to put this one first. I do not have to put that one first. I can put them in any order. So E, SSN, the names have to match. Names don't match, it's not going to work. They can be in any order. Don't have to remember the order. What else do I want in there? E, name. Let's test the E, date of birth. We'll test that here. The others are not required. There's only 2 that are required. If we go back up there and look at this table, there's only 2 of these. I made a few extras. What's the constraint? I have to have a primary key, and this is the constraint that says check null E name, check that E name is not null. So I have to have a name. Okay, so I do. I say I have to insert the ESSN, the E name, and I'm going to go ahead and insert the EDOB just to check to see that I have that format right. If I don't, I'm going to fix it. Then the next line. Typically the next line. It could all be on one line. SQL is not fussy about line breaks. You can break the line any place you want to. Break it where it makes sense. It is possible to write SQL code that is unintelligible. So fuss over your format, that it is readable and that it looks like what you're trying to do. Right? So as I glance at this, I can see what I'm trying to do. Values. Now, a minute ago, when I was listing those fields, it didn't matter what order I listed them in. Now the order matters. I have to match that one that is. So I could put eName first. If I put eName first up here, that's fine. Put eName first. I typically keep the same order, but if I have access to that create table, I usually do. So ESSN. Now, what kind of a field is it? What type is it? It's primary key. Type means integer, floating point, char, what? character. So it's a character field with nine characters in it. It does not have to have 9 characters. It says if I don't use 9 characters, it will pad it out with blanks for me. So I'm not going to use 9 characters because I don't feel like typing 1, 2, 3, 4. I could just as easily have put in A, B, C, D. Close. Single quotes. SQL uses single quotes. If you see me use double quotes, you say, Dr. Smith, you're writing C code. This is SQL. Comma. Next one is the name, employee's name, Joe. Next one is the date. A date field is typically put in quotes and single quote. Let's put it in, see if we get it this way, 07. 09. Oops. Okay, behold the insert statement. We're about to get Joe. It is possible if you don't feel like running the whole thing, it is, I'm gonna have to run the whole thing because I've added that date field to it. So I'm gonna have to run it. If I execute it, it says, it gives me that word 1 row affected. I will show you how to turn that off if you don't want to look at it later. I don't care right now. It tells me that they'd inserted that row. To see what I put in, I can issue this select. Everything, star means everything, select everything from employees. Now this one, I don't feel like running the thing again, so I'm going to execute that. And I may have my dates backwards. I think I've got them backwards here. Year first, then the month, then the day. Yeah. Okay. So year, month, day. Let me go correct this. So this is backwards. So it's 4-digit year, and you can change this. So we're going to see later that I can insert them any way I want to. I just have to tell it how I'm inserting them. But the default is year, month, year, month is the default. If you don't say otherwise, that's how it goes in. Okay. This one, if I go over here to the GUI and I go, let's see, this is in the Scratch database. If I go to the Scratch database, the database I'm using, I go to the tables, I can see the table's employees. There's my table. If I right click it and I say, edit the top 200 rows, I get a window. And there is my Joe. There's Joe, 1, 2, 3, 4, Joe. I can insert data here. I can change data here. That's not what this class is about. But if I just want to put some data in there just to see how my SQL is working, you're free to use it. But we're not going to actually use it in the class. I'm just pointing out that you can get to the graphical user interface. You can also create tables over there, but we're not going to do that. Okay, I've got a parent, now what? How about the kids? Insert into dependents. Okay, now I give it the field list. What are the fields of dependents? DSSN, DNAME, okay. DSSN, let's go 9876. Go backwards for dependents. What's this? This is Joe Jr. Oops, 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 oops. I'm putting in values. Forget what I just did. D, SS, SS, N, D, name, E, SS, N. Got to put the field list first. Got ahead of myself there. Values. Joe Jr. Who is Joe Jr.'s sponsor? Well, I've only got one. If I had two, I'd have a choice. I don't have a choice. So Joe Jr.'s sponsor is 1, 2, 3, 4. I can just execute him alone because everything else has run. Now, maybe if you want to, now you copy and paste is your friend with these. Instead of typing it, instead of typing that line, insert into dependence DSSND name ESSN over and over and over again, use copy and paste. But maybe you don't like that. Maybe you want to do it this way. Maybe instead of this way, maybe you want to do it like this. Maybe Joe has 2 dependents. Or maybe if I had multiple employees, I want to insert all of the dependents with a single insert. That's fine. Commas go between them, as many as you want. Typically what I do is I take one of them, create a dummy one where these values are out of it. Sometimes you'll use C or perhaps Perl or another language to generate SQL, and then you run the SQL code. That's typically what you do to import data. Either you're doing that or you're doing that in the background. So this now should affect 2 rows. If I say execute, notice I got 2 rows affected here. 1 row, put in this guy, and then this put in the, so if I wanted to know what Sally's sponsor's name was, and let's say I have lots of dependents and lots of employees, I want to know Sally, okay, and not Sally, but I want to know dependent 8765, what is his or her sponsor's name? Can I find it? I go to this field, get that, go up to the employees table, look up that field, and grab the name. Her sponsor's name is Joe. Okay. If I want to say, show me all of Frank's kids, look up Frank. I might have 2 Franks, might have 10. Get their social security number, go to the dependents table, look up all of those guys, and go ahead.
So in the dependence table, does it store ESSN as something or store as a reference to?
Yeah, it stores it as a, well, reference typically means a memory address link. The answer is you don't know. You don't need to know that. Lots of stuff in database, you don't really need to worry about it. How it does it, the database does it. Databases are very, very complicated pieces of equipment. And I'm not going to try to second guess it. I suspect it stores it as characters, and it just searches. Databases are optimized for searching. It probably sets it up in a very complicated data structure that makes searching a disk very, very easy. So searching a disk for a primary key, since they're ordered by that primary key, it becomes very, very quick. I can do a binary search on it. Not just a binary search, but I can do one that is much faster than that. So I can get a very, very high-speed search. Okay. It just does it very efficiently. Databases are very consumptive of your resources, but when it comes to putting stuff to the disk and getting it off of the disk, they're a searching and sorting machine. That's what they do. Okay, questions on insert? Pretty straightforward. All right, let's look at the next one. Examples. Strings are always single quoted. Double quote is never used in SQL. What, never? Yeah. SQL is not case sensitive. SQL is open format, but your teacher is not. Your teacher is fussy about format, but your teacher will not try to tell you exactly how to do it. He will make suggestions. Don't fuss over your format. Worry about think about how you can make it more obvious, because I like code that is obvious to me what you're saying. And when it isn't, I'll make suggestions. Right? If you follow along with what I'm doing, sort of. SQL Server does not require closing semicolons. However, I do. Pay attention to that. I do take off when there is no closing semicolon. So things I'm fussy about are closing semicolons. If you move to some other platform, you will have to. Okay, what else? Other thing I'm fussy about is at the beginning of all of your programs, I want to see that. You get about one warning on that, and then I start taking points off if that use statement does not appear. Closing semicolons, if you miss one of them, it is not a good habit to get into just forgetting about them, because they have to be there in many implementations. This particular one we're in will allow you to get away without it. Okay, let's go to the next. What's the next one? Is update. Database programming is very unforgiving. Changes are written to the disk as the code executes. Okay, this means that you do not have an undo button on a database, because an undo button says it has to keep a copy of what you've done. You may have done something rather major there. Now, that said, you have what they call a rollback to some extent, but if you do too much in one swell foop, you can outdo your undo capability, because you have to keep the old copy and the new copy, and you might not have enough room for that. You might do something that is just so big that you can't keep a copy of everything you did. Okay, be careful. SQL is unforgiving, particularly when you start updating the data. I'm changing data. If I do an insert, I can always delete it. If I accidentally insert something that I didn't want, I can always undo that, because it's called delete. Updates are not the same, so there's your caution. This is one of the more difficult areas of programming, because you can do so much damage. We don't have enough memory to work on a copy. While there exists, it can be a little bit safer. Remember this axiom. SQL has a similar undo ability as the M16, okay? Just think no undo. Yes, we do. We can run logs and we can run backups. And have you hugged your backup today? So you can restore from tape, yes. Your database people will not like you, because that means you have to shut the database down for a while. Okay, update syntax is covered on page 224, 225. Basically, it looks like this. Update, table name, set, the column name to a value, can have more than one, and then you can have where something, okay? So, for example, if I wanted to change Sally's name to Susie, it would look something like this. Okay, Sally is in the database. I say update. I don't know why this turns pink. Maybe it's turning red, saying be careful. Update dependents, set dname. Yes. I guess that's how you spell Susie. Okay. Be careful here. If you execute that, you're going to change them all to Susie. Okay. Yeah, be careful. Where? D SSN is equal to 8765. Semicolon. You get equal to, here we have less than, greater than, work, greater than or equal to, less than or equal to. I'm going to talk more about those when we get there. If I execute this, one row, and now if I were to select everything from dependents, we're going to spend a lot of time on that select statement. So you're seeing something that's just from, to see all of the stuff in there, and select everything from dependents, and notice that Sally's name changed to Susie. I know that's kind of hard to see, but take my word for it. Or get new glasses, one of the two. Okay, questions? I'm not going to spend a whole lot of time on this. We're almost out of time. I wanted to get to the next one. These are examples. You can update. It'll update as many rows as meet that where clause. So if I said where it does not equal, I would have updated the other one. I would have updated everybody else. Be careful with it. That said, it's your database, the AP database. If you trash it, you can put it back very quickly. So it's not a problem. Delete statement, be careful, undo ability. Yes, I cover all that. Okay, basically it's delete from table name where the value. So if I were going to delete, again, be careful what happens if I just execute that line without the where clause. You just by table. Oh, but that was my employee. That was my HR table. Oh, maybe I better get out my resume. It's called a resume generating moment. Let's see. What is it? 8, 9. Okay, let's delete Joe Jr. Sometimes I usually will put spaces there. They're not required. Again, it's an open format where spaces go. Isn't real important as long as they're not in an identifier. So if I were to execute this, bingo, I have just deleted Joe Jr. He's not there anymore. I'm not gonna belabor this. Delete all data. Oops. Be very careful. You don't have an undo. Thank you. There's a little bit of an undo. Let's see. Delete. I'm talking about here how we can get around it, and instead of deleting, I can have a field called active. Active is a Boolean field. It probably should be a tiny int. It's one word, TINYINT. That's 1 byte, and it is 1 or 0. and then I can use the select to see only the active records, and when I want a record not to be active. We almost never delete from a database. In fact, in my databases that I build, I usually block you from deleting. Just because, hey, you're in the Collin College database. When you are no longer a student at Collin College, are they going to delete your records? No way. If you're running a medical database for a doctor's office and a patient is no longer the doctor's patient anymore, the patient leaves, moves, dies, I don't know. Do you delete that patient's records? No, never. You've got them forever. Right? The IRS can go back and pull up your records from as long ago as needs to be, even people who have passed. So you almost never, databases almost never shrink. Almost never do you do delete, although we're going to do it just to practice using it a little bit. I'm not going to talk about triggers right now.
Is there no Boolean type?
No Boolean type. No, there's no built-in type called Boolean. In reality, most languages that have a built-in data type called Boolean don't do it as 1 bit. I've never seen it implemented as 1 bit. When I've really looked into it, it's always been a byte. Sometimes it's 4 bytes to just store true or false. So what's the point in having a, wait a minute, SQL Server. I'm going to have to look that up and get back to you. SQL in general does not have Boolean. Now, SQL Server might. This is the first time I'm not used to teaching an SQL Server. I've been teaching this one a while here. But I think there's one of them that does, and it might be SQL Server. But I don't need it. Just because it's more work to tease out 1 bit, than it is just to go ahead and allocate a byte. Create table with insert. I don't know what this is. Oh, this is creating a table. Create table. Well, it just puts the insert into a single. This is just a big script. You can look at that. Update and delete. I don't know why I put this in there. It's not real important to me. Okay, I think I've covered everything. I've covered creating a table, and then we took a break, and then I covered insert. Insert is probably the most important one. You have to insert the parent table, the parent field, before you can insert the data into the child. Then after you insert, you can update it, or you can delete it. So insert, update, delete, and then we have seen briefly select, but select is going to be a huge part of this class as we move on. So that's next week. So we're coming up on select for next week. I'm going to make modules 3 and 4 due Wednesday, I think. But if you want to take Friday, that's fine. I typically will grade them together. So it's okay if you want to put them in the same file. You don't have to have a different file for module 3. Do please turn me in something for module 3 and something for module 4, even though they might be the same file. That's okay. So I don't care whether, you can do the inserts at the same time, then just turn in the same file for both modules. If you don't, it doesn't ever open a grade for you. So you have to turn in something for both modules. Whether you you don't have to go take the inserts out of module 3. If you do them both in the same file, just turn in the same file, that's fine. I'll just grade one file. Okay. But I have put grades in 2 places. Questions? Okay. Okay, I have my headphones on now. Wesley, questions?
No, I'm good. Can you hear me?
Yeah, I just unmuted you.
Okay, yeah, I'm fine.
Okay. Well, we're about to end the recording. Josh, you okay?
Yeah, I'm doing great.
Okay. Mohammed, are you there? Mohammed. Paging Mohammed. Okay, that's fine. Everybody, any questions? Mahed, you have a question? Okay, I'm going to post the recording here in just a few minutes. I'm going to end the I'm going to end the recording here, and then I'm going to end the meeting, and then I will have the recording posted and live here in just a few minutes. Okay. Ta-ta.